Hi everyone, we're going to find the 2 points that define the latus rectum given the focus and vertex at 0, 0. We're going to write the equation and graph it. This is part 1 because part 1 is the vertex is at the center or at the 0, 0. And part 2 is going to be where the vertex is at a different HK than 0, 0. And the thing you need to notice when you're looking at these is what's changing. So this is my first problem here, and what's changing is the x. What's changing at number 2 is the y on number 3, and x on number 4. So for number 1, it lies on the line y equals 0, because the 0's here, so it's y equals 0, because you have both of these 0. On this one, they both lie on the line x equals 0. On this one, same thing, x equals 0. And on the last one, these two are the same, so they're both gonna lie on the line at y equals 0. Alright, so this is number 4. And for number 1, since it's y equals 0, and a is 4, because from 0 to 4, 0 to 4 is 4, that means it's going to open to the right of 0, 0, because that's going to go to the right. So that means it opens to the right. I'm going to look at this one next. This one means it's going to open to the left, because we're going to the left for number 2. This one's going to be 2 is going to be opens up, because it's 0 to 2 and the focus is at 2, so this opens up. And what changes here is the y, so that's going to open down. And if you can recognize those, that makes it easier. So the first one we're going to do is number 1, and we have the focus is at 4, 0, and the vertex is at 0, 0. So that's the vertex, that's the focus, and so that means we know it's going to open to the right. Also, our directrix then would be 1, 2, 3, 4 this way, because the vertex is always the midpoint. Okay, so the directrix is going to be x equals -4. Now we have to find the points that define the latus rectum. So since this opens to the right, it has the form, my equation has the form as y squared equals 4ax. Well, my a is 4, because I went 4 to get to the focus at 4, 0. And so my a is 4, so I get y squared equals 4 times 4x. So we have y squared equals 16x. That means the length of my latus rectum is 16. So from here, I can go up 8. 1, 2, 3, 4, 5, 6, 7, 8. And down 8. 1, 2, 3, 4, 5, 6, 7, 8. And from the vertex, I'm going to graph this like this. Very wide. The points that define the latus rectum are therefore 8, 0. Oh, sorry. Changing the y. 4, 8. And 4, -8. And how you really do that is you look at the, if you don't want to do it by the graph, we look at the focus, which is 4, here, and we plug it into our equation here. So we get y squared equals 16 times 4. It's like you're doing a table of values. When x is 4, what would be your y? So we get y squared equals 64. You square root both sides, you get y equals plus or minus 8. That's why I went up 8 here and down 8 here for the negative part. And this whole length equals, of course, 16. 8 plus 8 is 16. Alright. Okay, the next one, we have a focus at 0, 2. And the vertex is 0, 0. That means it opens up. The directrix would be at y equals negative 2. This is going to open up. Now to get the form if it opens up is x squared equals 4ay. And therefore my a, since I went up 2, is 2. So I'm going to write x squared equals 4 times 2y, because your a is 2. Let's write a equals 2. So we get x squared equals 8y. Now from here, since I already kind of have a graph here, the length of my latus rectum is 8, so I'm going over 4. 1, 2, 3, 4. Over 4 this way, 1, 2, 3, 4. And it opens up, something like that. Okay? We know our A is 2, and if you want to do it the other way besides the graph, you would plug in your y, which your y is what? 2. So you go x squared equals 8 times 2, so x squared equals 16, so x equals plus or minus 4 when you square root both sides. Alright, so that's why I went over 4 this way, over 4 this way, and this whole length is 8. And the next one, we had the focus at 0, negative 3, and the vertex is 0, 0. That means we know it opens down. I could also draw the directrix. I don't think we have to, but I'm going to. So this is going to be y equals 3. We know it opens down, and I just need to find the points. So let's use our equation. Since it opens down, it has the form of x squared equals negative 4ay. Since we're going down 3, or the a equals 3, because we're going down 3 and up 3 for this, we're just going to write x squared equals negative 4 times 3y. So x squared equals negative 12y. That means if you want to graph this, we're just going to go from the focus, which was 0, negative 3. I'm going to go take half of 12, and I'm going to go over 6. 1, 2, 3, 4, 5, 6. Over 6 here. 1, 2, 3, 4, 5, 6. And then just draw it down. Alright? Now, to not graph it, so this whole length here, let's do this. This whole length, I'm writing this upside down. This whole length here should be 12. The negative means it opens down. You can plug in your negative 3 to find this point here and this point here. So if I plug negative 3 into the y, we get x squared equals negative 12 times negative 3. So we get x squared equals 36. You square root both sides, you get x equals plus or minus 6. And that's what we did. We went over 6 to the right and over 6 to the left. And the last one is the focus is at negative 4, 0. 1, 2, 3, 4, 0. The vertex is at 0, 0. That means it's going to open to the left, so it has this form y squared equals negative 4ax. I'm going to go ahead and put in my directrix and go this way. My A, therefore, is 4. And go over 4 here and draw my directrix, which is x equals 4. And now to get the points of the latus rectum, I just plug in, if my A is 4, I'm just going to plug it into my equation, y squared equals negative 4 times 4, which is my ax. So y squared equals negative 16x. And again, from here, your focus, which was negative 4 comma 0, I can go up 8 and down 8, which I think is here. And then it's just pretty wide here from your vertex, which is 0, 0. And it's getting into that area. Or you could just plug in, again, your negative 4 into your equation. That's going to give you y squared equals 64. You square root both sides, you get y equals plus or minus 8. We went up 8, and we went down 8. And the total length of the latus rectum is 16. And that's all. The next set we're going to do is where the vertex is not 0, 0, but it's going to be shifted on the graph. Thank you. Have a nice day. Bye-bye.